Probability. A coin is tossed once. Find the probability of getting a head. Coin is tossed once. S is the set of all possible outcomes. So when you toss the coin, you might get head or tail. This is a sample space. NFS is equal to 2. There are two possibilities. E, that is event of getting head. So number of chances in one toss of getting head is 1. So probability of getting head is equal to N of E divided by N of S. N of E is 1 divided by N of S is 2. Therefore, probability of getting head is of 1 by 2. Two coins are tossed once. Two coins are tossed once together. Find the probability of getting two heads, at least one tail. Sample space, set of all possible outcomes, both coming as head and one tail, one tail and one head, or both the tails. There are 4 possibilities. This is the sample space. Event of E1 is the event of getting two heads. Therefore, N of E1 is equal to 1. E2 is an event of getting two heads, at least one tail. At least one tail. E2 is an event of getting at least one tail. Here one tail, at least one tail. There are 3. N of E2 is 3. P of E1, that is probability of getting two heads, is equal to N of E1 divided by N of S. N of E1 is 1, N of S is 4. 1 divided by 4. This is the possibility of getting two heads is 1 divided by 4. Then probability of getting at least one tail, that is P of E2 is equal to N of E2 divided by N of S. N of E2 is 3, N of S is 4. In all the probability problems, denominator always you get N of S, the number of all possible outcomes. N of S is going to be denominator in all the problems. A die is thrown once. What is the probability of getting an even number, a number greater than 2? Sample space S is the sample space, that is 1, 2, 3, 4, 5, 6, sum of all the events. So number of events is 6. Number of possible outcomes is 6. Even the event of getting even number, there are 3 even numbers, 2, 4, 6, 2, 4, 6. Number of even numbers is 3. E2 is an event of getting a number greater than 2. The number greater than 2 or 3, 4, 5, 6, 3, 4, 5, 6. There are 4 numbers which are greater than 2. Then probability of getting an even number is equal to P of even is equal to number of even numbers divided by the total number of events, total number of outcomes, that is 3 by 6, that is equal to 1 by 2. Possibility of getting a number greater than 2 is equal to P of E2 is equal to N of E2, the number of terms which are greater than 2 divided by N of S is equal to 4 by 6, that is equal to 2 by 3. A die has 6 faces marked as 1, 2, 3, minus 1, minus 2, minus 3. These are the faces of a die. The die is thrown once. What is the probability of getting positive integer greater than minus 3 and the smallest integer? S, the sample space, set of all possible outcomes, is given by 1, 2, 3, minus 1, minus 2, minus 3, then number of outcomes is equal to 6. Even. Event of getting a positive number. Even is the event of getting a positive number. Positive numbers or 1, 2, 3. Positive numbers of 1, 2, 3. The number of positive numbers is 3. E2 is an event of getting greater than 3. Greater than 3. There are other number 1, 2, 3, minus 1, minus 2 or greater than 3. Minus 2, minus 1, 1, 2, 3 are greater than 3. Number of terms greater than 3 is 5. E3 is an event of getting the smallest number. The smallest number among all the 6 is minus 3. Minus 3 is the smallest number. Number of smallest numbers is 1. These are the number of even numbers, number of positive numbers. These are the number of greater than minus 3. This is the number of smallest number. This is the one number is smallest. The possibility of getting the positive number is equal to n of even divided by n of s. N of even is 3, n of s is 6, that is equal to 1 by 2. P of E2, that is possibility of getting a number greater than minus 3 is n of E2 is 5, n of s is 6, 5 by 6. Possibility of getting the smallest integer is n of E3 divided by n of s is equal to 1 by 6. In all the probabilities, n of s comes in the denominator, and these are the things which you have calculated here. Cards marked with numbers 1, 2, 3 up to 10 are well shuffled. A card is drawn at random. There are 20 cards, and that one card is drawn in random. What is the probability that the number on the card is a prime number? The card which we have drawn, what is the possibility of getting that as a prime number? A number divisible by 3. The number which we have, the card which we have drawn, the number on that divisible by 3, and a perfect square number. S is the sample space. These are the outcomes 1 to 20. Then number of outcomes is going to be 20. The even is the event of getting a prime number. There are so many even numbers: 2, 3, 5, 7, 11, 13, 17 and 19. The number divisible by the number 1 and number itself for the even numbers. So total number of even numbers from 1 to 20 is 8. N of even is 8. E2 is an event of getting number divisible by 3 from 1 to 20. So these are the numbers which are divisible by 3. 3, 6, 9, 12, 15 and 18. So number of numbers which are divisible by 3 from 1 to 20 is 6. E3 is an event of getting a perfect square number from 1 to 20. 1, 4, 9 and 16 are the perfect squares. Here you need to be careful because 1 is also a perfect square. We might forget that 1, we might forget the 1 because we usually take 2, 3 and 4 as perfect squares. So 1 is the 4, 9 and 16 as perfect squares. 1 is also a perfect square. Then P of E1 is equal to N of E1 divided by N of S. P of E1 is 8. N of S is 20, that is 2 by 5. P of E2 is equal to N of E2 divided by N of S. Then 6 by 20, 6 divided by 20, that is 3 by 10. P of E3 is N of E3 and N of S is equal to 4 by 20, that is 1 by 5. All the denominator is N of S, N of S, N of S, N of E1, N of E2, N of E3. Once you make these sets properly, then the number of events, number of things, number of prime numbers, number of the numbers terms divisible by 3, then perfect squares. If you do all these things properly, find out. So this will be very easy. Just substitute in these things. A game of chords, a game of numbers has chords marked with 11, 12, 13, 14, 15, 16 up to 40. A chord is drawn at random. Find the probability that a number on the card is a perfect square from 11 to 40, and a divisible by 5, a divisible by 7 from 11 to 40. So 11 to 40, you should not get confused with the 40. There are no 40 numbers here from 11 to 40. So S sample space, so from 11 to 40 is 30. Sum of all possible outcomes is only 30, not 40. 40 minus 10, that is 30. Even is the event of getting perfect square from 11 to 40. Just see, 4 4s are 5 5s are 6 6s are 36, 7 7s are 49. It goes beyond 49. 3 3s are 9. It comes before 11. So we have only 3 perfect squares. Number of perfect squares n of even is equal to 3. E2, event of getting number divisible by 7 from 11 to 40. 7 2s are 7 3s are 7 4s are 7 5s are 7 6s are 42. It goes beyond. Then so these are the numbers which are divisible by 7, 14, 21, 28 and 35. So number of numbers which are there which are divisible by 7, and this 11 to 40 is 4. Once we know all these three, rest will become easy. This is going to be the denominator. P of E1 is equal to n of E1 3 divided by n of S 30, that is 1 by 10. P of E2 is equal to n of E2 divided by n of S. N of E2 is 4, n of S is 30, that is equal to 2 by 15. A box contains some black balls and 30 white balls. There are black balls and white balls in a box. There are some black balls and 30 white balls. If the probability of drawing a black ball is 2/5 of that of drawing a white ball, then find the number of black balls in the box. We need to find the number of black balls in the box. So n of E1 now is equal to x. Let the number of black balls be x. N of E1 is the number of black balls which we have taken it as x. Number of white balls, n of E2, they have given it as 30. These are white balls, 30 white balls, number of white balls. N of S, the total number of balls in the box is number of black balls plus number of white balls, that is x plus 30, total number of balls. The probability of getting even black balls is equal to n of E1 divided by n of S, total number of outcomes, all possible outcomes. That is equal to number of black balls is x divided by x plus 30. Then P of E2, the probability of getting the white ball is equal to, they have given n of E2 divided by n of S. So number of white balls is 30 divided by x, total number of balls is x plus 30. And they were given one condition here. The probability of drawing a black ball is 2/5 of that of drawing a white ball. The probability of drawing a black ball is equal to 2/5 of drawing a probability of drawing a white ball. Therefore, what is the probability of drawing a black ball is x divided by x plus 30. X divided by x plus 30, that is equal to 2 by 5 into probability of drawing the white ball is 3 by 30 divided by x plus 30. X plus 30, x plus 30 got cancelled. 5 6 are 30, 6 2s are 12. X is equal to 12. Number of black balls is 12. From a pack of 52 playing cards, all cards bearing the numbers which are multiples of 3 are removed. All the numbers which are multiples of 3 are removed out of 52 playing cards. A card is now drawn at random. What is the probability that the card drawn is a face card? A face card means king, jack or queen. An even number red card. An even number card which is red card. Before getting into the solution, let us see what all there in the playing cards. In the 52 cards, there are 4 suits: spades, clubs, hearts and diamonds. Spades will be there in this shape, clubs will be in this shape, heart will be in this shape, diamond will be in this shape. There are 4 suits. In each suit will have 13 cards of spades of this shape, the clubs of 13 of this shape, and hearts of 13, and diamonds of like this. The spades and clubs are black, hearts and diamonds are going to be in red. There are 13, 13, 13, 13. There are 4 suits here, 52 cards. In this, the first A will be there, the next 2 to 10 will be there, then King, Queen and Jack will be there. King, Queen and Jack. These are the types of cards which will be there in the 52 cards. There are 4 suits, spades, clubs, hearts and diamonds. These are the shapes, 13, 13, 13 will be there. From 2 to 10 there are numbers. Then these are the letters. Among those cards, we are going to remove the multiples of 3. What are the multiples of 3 between 1 to 10? Is 3, 6, 9. 3, 6, 9. There are 3 cards, multiples of 3 from 1 to 10. There are 4 suits, spades, clubs, and hearts and diamond. There are 4 types of cards, suits. So in each suit we have 3 cards, that is, which are multiples of 3, 3, 6, 9. There are 3 cards. There are 4 suits. There are therefore total number of cards which are multiples of 3. Number of cards removed from 4 suits. 12 cards we are going to remove out of 52 cards. So therefore N of S, sample space, total number of cards which are there for removing the cards, that is 52 minus 12, that is 40. These are the total number of cards remaining after we removed the multiples of 3 out among all the 4 suits, which were 12. 12 we removed, out of 52 we removed 12, then left out is 40. Even an event of getting a face card is 3, K, J, Q, E. Number of cards is 3 into 4. There are 4 suits. In each suit there are 3 cards, K, J, Q. There are 3 cards in each suit. There are 4 suits, that is 12. Number of face cards are 12. Then probability of getting a face card is equal to number of face cards divided by total number of cards, that is equal to 12 by 40, that will give 3 by 10 probability of getting a face card. Second event, E2. E2 is an event of getting a numbered red card, even numbered red card. Even numbered red card. There are 2, 4, 6, 8 and 10 are there in the even cards from 1 to 10, but we have removed 6 because it is divisible by 3. We have removed. Before taking the card out, we have removed the numbers which are divisible by 3, that is 3, 6, 9. The 6 we removed. Then the other even numbers left out in the cards is 2, 4, 8 and 10. There are 4 on each suit. So number of cards, even cards left out is 4 into 2 is equal to 8. See, number of even numbered red cards, so only in red and diamond. So we would have taken 4 here if they would have told all the cards. There are 2 black cards also in other things. There are 2 suits which has got red and 2 suits which has got black. That's why we are taking only 2, because we want only the red cards. Numbers of even numbered red cards, that is there in hearts and diamonds. In spades and clubs we have black cards. There are 4 even numbers left out because 6 we removed in each suit. There are 4 suits, but we need only red. There are only 2 red suits. 4 into 2, that is 8. So probability of getting even red card is number of red cards divided by total number of cards, that is 8 by 40 is equal to 1 by 5. 2 dice are thrown simultaneously. What is the probability of getting 9 as sum of the 2 numbers that turn up when we throw 2 dice, there are going to be 2 numbers turning up. When we add those 2 numbers, what is the probability of the sum of those 2 numbers as 9 and getting a doublet, having the same number on both the dice? The sample space S, when we throw 2 dice, the upper face may be 1 and 1, 1 2, 1 3, 1 4, 1 5, 1 6, or 2 1. This is the first dice and second dice simultaneously be thrown. These are the probability sum of all possible outcomes. First dice may be 2 1 or 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. The total number of outcomes is going to be 30. All possible outcomes, total number of all possible outcomes is going to be 36. In that we want, what is the possibility of getting when the numbers, when we add and both the dice is going to be 9, we have 4 chances of 3 plus 6 is 9, 4 plus 5 is 9, 5 plus 4 is 9, and 6 plus 3 is 9. So one more thing, there are doublets. Doublets are 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. There are 4 possibilities of getting the sum of them as 9. There are 1 2 3 4 5 6 possibilities of getting doublets. Even an event of getting 2 numbers whose sum is 9 is 3 6 4 5 5 4 3 6 3. The number of chances is 4 1 2 3 4. Then probability of getting even, that is sum equal to 9 is equal to n of even number of time. This thing possibility is 4 divided by total number of possibilities, that is n of s is 36, 4 by 36, that is equal to 1 by 9. Probability of getting even, the sum of the 2 turned of dice 9 is 1 by 9. The E2 is an event of getting a doublet. 1 1 2 2 3 3 4 4 5 5 6 6. The number of possibilities of getting the doublet is 6. The probability of getting a doublet is equal to number of doublets is 6. The total number of possible events is 36. 6 by 36 is equal to 1 by 6. The probability of getting a doublet. A bag contains 5 black balls, 7 blue balls, 4 white balls, and 6 red balls. In the bag, there are 5 black balls, 7 blue balls, 4 white balls, and 6 red balls. 1 ball is drawn at random from the bag. Only 1 ball is drawn. Find the probability that the ball drawn is red. The ball which you drawn is red. Probability of drawing red. The black or white. The probability of drawing the black or white. Or probability of not drawing blue nor blue, and the probability of not drawing neither black or blue. So these are the things we need to find out. In the bag, there are 5 black balls, 7 blue balls, 4 white balls, 6 red balls. Then we need to find out the probability of drawing a red ball, the probability of drawing the white ball, then probability of not drawing blue ball means then we have to take out the other balls which are left out, be black, white and red, and nor black and red means then there is a probability of drawing white and red. Not drawing blue ball means then there is a probability of drawing these things. We have to take black, white and this thing. We have to take the total of black balls, white balls and red balls. S is the sample space. There are 5 black balls, 7 blue balls, 4 red balls, 4 white balls and 6 red balls. Total number of balls 5 plus 7 plus 4 plus 6, that is equal to 22. That is the possible outcome of the thing. So n of even, that is number of even is the event of getting red ball, Therefore, number of red balls is equal to 6. Probability of getting a red ball is equal to number of red balls 6 divided by number of total balls n of s. N of E1 divided by n of s. N of E1 is 6. N of s is equal to 22. That will 3 by 11. This is the probability of getting a red ball. N of E2, where E2 is the event of getting a black or white. Black or white. There are black 5 balls, white 4 balls. These are the number of balls, total number of balls of black and white. Then N of E2 is equal to 9. Probability of getting black or white is equal to total number of black and white balls, N of E2 divided by total number of balls, that is 22, and 9 by 22. This is the probability of getting white or black ball. N of E3, where E3 is the event of getting a ball which is not blue. E2 is the number of event of getting a ball which is not blue. Which is not blue means other balls. What is the other balls? Black, white and red. These are the total number of balls other than blue. That is 15. 6 plus 4 plus 5 is 15. So n of number of balls other than blue is 15. Possibility of getting E3, probability of getting E3, that is not blue, that is number of other balls, n of E3 divided by total number of balls, n of s, that is equal to 15 by 22. This is the probability of getting not blue ball. The fourth one, E4. An event E4 is the event of getting a ball which is neither black nor blue. So not getting black or blue, that means getting the other white and red. So number of white and red balls is 4 plus 6, that is 10. N of E4 is 10. Probability of getting not getting black or blue, neither black or blue, is equal to N of E4 by N of S, that is equal to 10 by 22, that is equal to 5 by 11.